Okay, this is Algebra Lesson 2.4, Subtracting Real Numbers, and this is a picture of the stock market floor. You can see it looks like utter chaos, but we've looked at and talked about different things about the stock market, and what we're going to talk about today is subtracting real numbers, as in if the stock market value dropped, then you would have a value less a negative result. So we're going to talk about addition problems, and if we look at this one right here, we have 5 plus negative 3 equals 2. The equivalent subtraction problem to this one right here is just 5 minus 3 equals 2. Look at the second example. We have negative 2 plus negative 6 equals negative 8, and the equivalent subtraction problem is negative 2 minus 6 equals negative 8. So these say the exact same thing, just slightly different. An important thing, so the basic thing to remember is adding the opposite of a number is equivalent to subtracting the number, which is what we're seeing right here. Adding the opposite of a number is equivalent to subtracting the number. An important subtraction rule is to remember that to subtract b from a, you add the opposite of b to a. And here's the example. A minus b equals a plus negative b. And it works using real numbers. It would be 3 minus 5 equals 3 plus negative 5. The result is the difference of a and b. So now we want to look at some examples using the subtraction rule. So here, find the difference. The first example is 10 minus 11. And so to get the solution, we're actually going to rewrite this using the subtraction rule. So 10 minus 11 becomes 10 plus negative 11. So we added the plus sign. We work it out and we get the answer is negative 1. 10 plus negative 11 is negative 1. The next example, let's look at 11 minus 10. So we would rewrite that as 11 plus, if I can get my pen to work, negative 10. And here we have positive 11 plus negative 10. And as you can see, the answer would just be 1. In another example, we could have negative 4 minus negative 9. So this one is a little bit more confusing because we have a negative and a negative here. And the subtraction rule is that we're going to add the opposite of negative 9. And so that would work out as negative, oh, just a second, sorry, as negative 4 plus 9. And that's going to equal 5. One thing I want to make a note of, just so you remember this, is that 10 minus 11 does not equal 11 minus 10. Unlike addition, you can't change the order of these. It's not commutative. So the order does affect the answer in subtraction. You can't rearrange the numbers. So one thing you might be asked to do is to evaluate expressions with more than one subtraction. And as an example, here's a problem: 3 minus negative 4 minus 1/2. And to figure out the solution, we will, let's write the problem out again. So now we have, let me rewrite it here. Oops. Okay, so I fixed my error. So we can rewrite 3 minus negative 4 minus 1/2 by adding the opposite. So we would, instead of 3 minus, we change that to a plus. We have two negatives there. We can have a plus. Minus, so we're going to add the plus sign here, and then we have the negative right there. So what we end up with is 3 plus 4 here is 7, plus, and we still have the negative 1/2 there, and 7 plus a negative 1/2, you're going to end up with 6 1/2, because we just went backwards 1/2. We're not a whole number, so we're just at 6 1/2. So let's try some more examples. Let's try using the subtraction rule. We have negative 3 minus 5, and that would be negative 8. That one's not so hard. 2 is we have 12.7 minus 2 is going to be 2.7. These were fairly easy to do in our heads. Okay, in the next example, we have 1 minus negative 2 minus 6. So we have a double negative here. So we just sort of intuitively know that that turns to a plus. We have 1 plus 2 is 3, plus negative 6, and that is going to end up as negative 3. I left and came back, so I'll have to start all over. I'm not sure what I already told you. On this example here, we have 4 minus 2/3 minus 5/3, which equals 7, and then we have plus the negative 2 over 3 plus negative 5 over 3. And this problem could be done several different ways. I'll show you the way that the book is doing it, but I want to make a couple of other comments about it. So in this case, we're going to add the opposites here. So we're going to have, let me get the pencil, 7 plus 7 over 3, which is going to equal 14 over 3. And it works out, the mixed fraction part of that works out to 4 over 2/3. Or it actually, if you wanted to put it in decimal form, you would end up with something that looks like that. Okay, I also wanted to show you something else here. So with the same equation, I could make the denominators the same, which is I'll take 7 times 3 over 3, keep the rest of the equation there, and by doing this here, I end up with 21 over 3. My equation still stays the same here, minus 2/3 minus 5/3, and then I join the denominators, so I just end up with 1/3 here. And now I have this part of the equation, 21 minus 2 minus 5 equals, and I have, when I simplified, 14 over 3. I convert it to a mixed fraction here, which is 4 and 2/3, and then I can convert it to a to my decimal, and the decimal form is 4.666, and round it to put a 7 there. Same problem, slightly different way to do it. So you could do it either way. There's some other slight variations on doing it, but as long as you kind of get the idea. Okay, so next you need to know how to evaluate a function if y equals negative 5 minus x, and x is negative 2 or negative 1, 0 or 1. And so in each one of these, you're basically working out an equation, but it's going to ask you to put your results in a table. So you would organize your table like this. We have input, function, and output here. And hang on, I'm trying to get an arrow. Okay, so here we have the first one, the negative 2. So x, the input, what we're putting into our function, because we don't know x here, the x is x equals negative 2. Here we would have x equals negative 1. Here is x equals 0, and here is x equals 1. So these are positives, these are negatives. So now we write out our equation. We have y equals -5 minus, and then we have to input what the first number is, and that's a -2. So now we have y equals -5. That's my cat meowing. She wants to go outside, apparently, but she can't because she doesn't have claws, so I don't know really what's going on. Sorry. Yep, you can hear. Maybe she doesn't like this particular algebra problem. I don't know. So when we work this problem out, y equals -5 minus -2. We got our double negative here. We want the opposite of -2. And so our answer here is going to be -3. On this one, we have y equals -5 minus -1. So again, we have the double negative, and we want the opposite of the negative. So that will be -4, because this one is, so you had -4, which basically works out to -4 plus 4, and you end up with -4. The next problem down here, we have y equals -5 minus 0, so there's nothing going to take place in that equation. I have to switch back and forth from my arrow to my pencil. And in the last one, we have y equals -1. Again, it's minus plus 1. And that answer is going to be -6. Okay. So a subtraction here, here, here always turns this into the opposite. Okay. Okay, so let's talk about, evaluate the function y equals 4 minus x. And do that when x equals -3, -1, 1, and -3. And show your results in a table. So just like we just did, we would draw our table. We have input here, function here, and output here. And we list what our x variables are. We have x equals -3, x equals -1, x equals 1, and x equals 3. And the first problem is, then we rewrite our equation right here, down here, and each time we put the different x variable right here. So on the first one, we have y equals x minus -3, and it's going to be the opposite of this. So it turns out it's going to be it's going to be 4 plus 3. That would be 7. Here we have x minus -1. Opposite of 1 is going to be plus 1, so that answer is going to be 5. Y equals 4 minus plus 1. It's going to be the opposite. Again, subtraction. This is like a signal here saying, do the opposite, do the opposite, do the opposite. Okay. 4 minus plus 1 is going to be -3. Oh, sorry, my pencil's not working. 3. And on the last one, y equals 4 minus +3 is going to be 1 again. So in every case, these turn into the opposite, and that's how you get your answer. Just a couple of other problems just to make sure that we're on the same page here. So if you had -6 minus 3, you know immediately to rewrite it like this. It's -6 minus +3. Once you do that, you know that this, because we have a subtraction here, this becomes the opposite. And so it turns out that it is -6 basically is what it kind of works. Let's see. Okay, so I erased what I had there. Didn't mean to confuse you. I wanted to show you a different way of visualizing this. So -6 plus -3 here equals 9. I did the opposites of what is shown here. Down here we had 5 minus 9. So this one, and just sort of a way to visualize this, we could do 5. I'm just showing you the opposites here, because that's visually a way to look at it. 5 minus 9 equals 5 minus positive 9. So that's how we would rewrite it. But visually, we could think that once we see it in this form right here, we can turn it into opposites. So we have 5 plus negative 9 is going to equal negative 4. And here we have negative 5 minus negative 6. If I do the opposites, I would have negative 15 plus 6 equals, and my answer would be negative 9. So visually, the orange is kind of how your mind might see it. So let's look at one more example. This is 10 minus 5 plus 14 minus negative 18. I can rewrite that as 10 minus 5 plus 14, do the opposite, plus, and plus 18. So then I have 10 minus 5 is 5. Wrote the plus 14. That comes out to 19. I bring my 18 down, and my answer is going to be 37. Okay, terms of an expression. When an expression is written as a sum, the parts that are added are the terms of the expression. For instance, you can write negative 5 minus x equals negative 5 plus negative x. And the terms then are negative 5 and negative x. And then you can use the subtraction rule to write the expression, or to solve it. I just want you to know that if I asked you what the terms of an expression were, that you could say here negative 5 and negative x. So for example, if I said negative 9 minus 2x, and I asked you to find the terms of an expression, you could use the subtraction rule to rewrite the difference as a sum, which would mean you would rewrite this to look like this. Okay, so negative 9 minus 2x would equal, when you rewrite it, negative 9 plus negative 2x. So all you've done is add the plus sign here, and then the terms are negative 9 and then negative 2x. That's the terms. If you don't rewrite it like this, though, you can get confused. So that's why you have to first rewrite it. Rewrite it and then identify. Can't spell identify. Identify the terms. Okay? So if you were asked to find the terms of x minus 3, you know that first you have to rewrite. So that would be x plus negative 3. And then you identify the terms, which will be the x and the negative 3. And so your answer then would be x and negative 3. If you were given the expression negative 2 minus 5x and you were asked to find the terms, you would rewrite it to be negative 2 plus negative 5x, and then you would identify the terms, which would be the negative 2 and the negative 5x. Don't forget the x here. My circle didn't include it. So in this example, we have negative 4 plus 6x. And I told you that you should rewrite it, but when it's an addition problem, we don't really have to. We can kind of visually see it. The answer here is -4 and 6x. That's the terms. The same would be if we had 7x plus 2. We know that the 7x will be a term and the 2 will be a term. So just know what terms mean. Now sometimes we are subtracting decimals, or we're using negative numbers to get a change in something from, for example, in the stock market, we had the closing price of something might be $21.38. Then the next day, the closing number, the value of that stock is 21.25. The next day it might be 21.38, next day 20.69, next day 20.06. And we want to track the difference. Well, if you use a calculator, it prints out when it's a negative, but for you automatically. But let's say that we want to see on August 24th what the difference was. We have to write the equation like 21.22 minus 21.38. Well, we can already see that this day was higher than the 24th. The 23rd day was 21.38 and today is 21.25. So we can see that automatically that is going to be a negative number. We could probably use mental math and figure out that the difference was 0.13, but because this is a bigger number than this, you're going to have a negative because you're subtracting a bigger number from a smaller number. Let me erase this part here so I don't have to redraw. So in this case, we would write down the answer to the problem there was a negative 0.13 change. If we go to the next day on the 25th, we would have 21.38 minus 21.25. We already see that this day is less than this day, so we're going to have a positive number. That's going to be 0.13. And so this day it's up. This day the value was down. Let me erase my bottom number equation here. And let's look at the next one. On the 26th, we had 20.69 right there, and we are subtracting from this one. Once again, I can see that this number is bigger than this number, so I know I'm going to have a negative, and the difference is going to be 0.69, and so the stock price went down. And I would do the same thing for the last one. It's going to be 20.06 minus 20.69. This day is bigger than this day, so I know that I'm going to have a negative 0.63 as my answer. Okay, your assignment, which starts on page 89 and goes through 91. You're going to do numbers 14 through 29, 36 through 41, the even numbers of 42 through 46, so I guess that's 42, 44, and 46. 56 through 63, all of them. 67 through 71, all of them. 75 through 77, all of them. And 81 through 83.